Good morning, students. Today we will discuss graphical representation of a vector. So we know what is a vector. Vector is a quantity which has both magnitude and direction. So it is represented by an English alphabet, putting an arrow over it. So this is a vector quantity. So this will have its magnitude and also its direction. So magnitude can also be written like this, and this will be the unit vector. In this case, suppose we want to represent a vector graphically, so we can use a coordinate system representation, like this is x dash, y dash. Suppose we have a point here, suppose the point is x, y. So this x is the distance from the origin along the x axis, and y is the distance from the origin along the y axis. So if we draw this line, this will represent the vector. So the vector which is directed from the origin, that is known as your position vector. So we can write like this one, that is OPR will be equal to xi cap plus y j cap. So this vector will have magnitude and direction. So the magnitude will be square of the respective components, their sum, then square root. So this is your magnitude. And how to find out the direction? Now this will be equal to, in this case you can observe, unit vector is equal to vector by its magnitude. So here I can write, this will be your vector by magnitude. So vector is xi cap plus yj cap. This will be square root of x square plus y square. So in this format, if the coordinates are given, we can represent that in a vector graphically. Also, if the directions are given with the magnitude, we can also represent the vector. For example, suppose it is given 2 meter along north. Suppose 1 meter along northeast. Suppose 2 meter 30 degree east of south. Now we will represent these three vectors graphically. So you see here, normal way of representing a graph with directions is like this. From the origin, upward will be the north direction, downward will be the south direction, right side will be the east, left side will be the west. Then suppose 2 meter along north. So north means like this. So I can write this one. So this is the first vector. A is equal to 2 meter towards north. Second one, 1 meter along northeast. Northeast means this and this quadrant. So we can write this one. The vector will lie in this quadrant. Now northeast, no angle is mentioned. So that means this will be at its center. So like that it will make 45 degree either with east or with west. 1 meter. So this will be the vector. Clear? Now suppose the third vector is 2 meter 30 degree east of south. So 30 degree east of south. So this will be in this quadrant, southeast. But 30 degree east of south. So we will start from south 30 degree towards east. So this will be like this. And the magnitude is 2. So this will be like this. So understood? So like this we can represent the vector graphically. Then also we can find out its different components along x-axis or y-axis. We'll take one example. Suppose there is a vector represent like this. So we have to draw the perpendicular to the respective axis. So this is x, this is y. Suppose this is making an angle theta. So this vector can be splitted into two rectangular components. One is suppose x. So let this magnitude is r. So I can write this one as cos theta is equal to b upon h. So in this right angle triangle, this will be x upon r. Similarly, I can write x is equal to r cos theta. Again sin theta will be equal to y upon r. So we can write y is equal to r sin theta. So for the vector representation we can write r is equal to r cos theta I cap plus r sin theta j cap. So these x is equal to r cos theta and y is equal to r sin theta. These two are known as rectangular components of a vector. Rectangular components of a vector. So suppose I am given like this. 2√2 meter along south west. So as already we have discussed, this will be north, south, east, west. So southwest direction means this quadrant. No angle is mentioned, so this is in between. This is 2√2 meter. So I can take angle with this axis or with this axis, and this angle will be 45 degree. So now we will represent this vector in terms of its rectangular components. So here, as we have already discussed, this is your vector r, this is your x component, this is your y component. So x will be equal to r cos theta. So that means 2√2 cos 45 degree. So this will be equal to 2√2 cos 45 is 1 by √2. So this will be 2. Similarly, y will be equal to r sin theta. So this will be also 2√2 into sin 45 is 1 by √2. So this is 2. So we can write this r vector equals to 2i cap plus 2j cap. So this is the simple way we can represent a vector graphically, if the directions are given also, and also if the components are given. Okay, thank you.